So in these questions here, when I have the opportunity to get the same base, that's what I'm looking to do, okay? I can't do these questions if I can't get the same base. So here, I can break 25 and put it down to 5 squared. And I can make 125 5 cubed. And that's really the key to the problem, is establishing the same base. Power to a power, we multiply. We're just distributing that exponent. And now when I have the same bases, that's what allows me to set the exponents equal. So 4x plus 2 equals 12x minus 15. Subtract 4x, I get 8x. Add 15, I get 17, and my answer is 17 over 8. The key is we've got to get to the same base, so therefore I can set the exponents equal. Same deal here, I need to use a base of 3 with 81 and 27. 3 to the 4th is 81. 3 cubed is 27. Power to a power, we're multiplying. 24x plus 8, 9x minus 15. And now I'm setting them equal. 24x plus 8 equals 9x minus 15. We subtract 9x, we get 15x. We subtract 8, we get negative 23. And my x is negative 23 over 15. All right, so in this case, we have the 1/8. That's going to convert to 2 to the negative 3. 2 cubed is 8, so 2 to the negative 3 is 1/8. And we're just distributing that negative exponent. 32, 2 to the 5th is x plus 5. Okay, so this becomes 2 to the negative 9x. Negative 3 times negative 4 is a positive 12. 2 to the 5x plus 25. Once I'm at that same base, now I can set them equal. Negative 9x plus 12 equals 5x plus 25. We add 9x to both sides, I'm going to get 14x. I'm going to subtract 25 on both sides, and I'm going to get negative 13. And my answer is going to be negative 13 over 14 equals x. Here, I'm going to make this 9 to the negative 2. 3x minus 4. And this 9 to the 2x plus 6, I can just leave it. 9 to the negative 6x plus 8 equals 9 to the 2x plus 6. Now, if one of you did 3 to the negative 4th and 3 squared, you'll get the same answer. That's okay. But hey, if I can make my life a little easier, why not? Right? You don't get bonus for degree of difficulty. I add 6x, I get 8x. I subtract 6, I get 2. And I get 2/8 equals x. I'm going to go with 1/4 as my answer. All right? But what we need to recognize is this raised to this equals this. So it's x to the 4th equals 16. What raised to the 4th is 16? 2. 3 to the 4th gets us to the x. 3 to the 4th equals x. My x equals 81. Here, 4 to the x gets us to 1 over 64. 4 to the x equals 1 over 64. That's negative 3. X to the negative 3 gets us to 1 over 125. So x to the negative 3rd equals 1 over 125. My x equals 5. Here, 5 cubed, so you got to go 5 to the 3rd, equals my x. My x is 125. And then finally, 2 to the x equals 64. Okay, 2 to the 6th equals 64. There's not really a lot of work. All right, so now when I expand here, okay, one thing that might help you out is in the back of your mind, you should know every term should have its own log. Now, the exponent doesn't get its own log, but every term has to get its own log. when we have an exponent, we should know. We throw it to the front. 3 log 3 xy divided by 4. And now the 3, that exponent goes here. So it's log 3 x plus log 3 y. Okay? The exponent comes to the front, and the plus sign represents that multiplication. Now the division sign is represented by a subtraction. So log 3 4. And that's what my answer should look like. That's expanded. Okay? Combined, I want to get it down to 1 log. The plus sign represents multiplication. The division sign, or the division, I'm sorry, there should be a minus sign here. We're going to make that a minus. I have to change that. My fault. So the plus sign represents multiplication, and the subtraction sign represents division. So I'll make that change for it. But it's really just xy divided by 6. Okay. Any questions with that? Concerns or issues? Okay. So now when we have the variable and the exponent and we can't get a similar base, I'm just putting the log in front of both. And essentially, if you have a base or a log without a base, it's assumed to be 10. But in this case, it's really not going to matter too much. Okay. The key to the problem is swinging the x to the front and then dividing both sides by what's next to the x. So this becomes log of 148 over log of 5. Here, log 3x equals log 74. We swing the x to the front. Log 3 over log 74, and we end up with log of 74 over the log of 3. Okay. Now you do have to go to your calculator to get your answer. So I'm going to head on over to my Desmos calculator, and this is where I do believe the Desmos calculator is pretty user-friendly. Okay. In this particular problem, once I get here, I'm literally just going to type the log in. I think it's easier. And we're going to get log of 148 divided by the log of 5. And we're going to round that to the nearest hundredth. It's 3.10. So when I go back to my x, I got to write that answer in there as 3.10. And here's a great check. 5 cubed is 125. 5 to the 4th is 625. So 5 to something to the 148 better give you a number between 3 and 4, which it does. If I do log of 74 over log of 3, log of 74 divided by log of 3, I'm going to get 3.92. Once again, 3.92. If I look at that, 3 to the 3rd is 27, 3 to the 4th is 81. To get to 74, I better get an exponent between 3 and 4. Down here, log 4x equals 258, and I swing that log to the front, or that x to the front, excuse me. And my answer ends up being x equals log 258 over the log of 4. Here, log 2x equals log of 37. I swing that x to the front, and now it's x log 2 equals log of 37, and my x equals log of 37 over the log of 2. I don't touch my calculator until I get there. You do have to show your work. All right, you're not allowed to just plug it into the calculator. You do have to show your work. And I get log 258 divided by log 4. Oops. And I get 4.01. Okay? In case you're wondering, 4 to the 3rd is 64. 4 to the 4th is 256. 4 to the 5th is much bigger than 256. So if I'm at 258, I should be slightly higher than 4, and I am at 4.01. This next answer should be 5 point something, because log of 37, log 2. All right, think about it. 2 to the 5th is 32, 2 to the 6th is 64. My answer should be somewhere between 5 and 6, and it is 5.21. So I'm going to put those two answers down. X equals 4.01, and X equals 5.21. All right. That plus sign represents multiplication. Log of 3, 7 times 4x is 28x. Log of 3 is 56. Since I have the same logs here, I can set these two terms equal. 28x equals 56. My x equals 2. With subtraction, that's division. Log of 4, 42 over x equals log base 3, 7. And this should be a 4 here, I apologize. I got a little careless there. You have to have the same base of the log, so I apologize for the 3 there. That should be a 4. So now it's 42 over x equals 7. I'm going to multiply x on both sides. 42 equals 7x. Divide by 7, and my x equals 6. Now, once again, if you know off the top of your head 42 divided by 6 is 7, and you just want to say x equals 6, I'm fine with that. That's fine too. Our last one, whenever you have that number in front of the log, it jumps to that exponent spot. So we're going to rewrite first. X squared plus log 3 equals log 3, 27. The plus sign means multiply. So it's 3x squared equals log 3, 27. And I'm going to take both these terms and set them equal. 3x squared equals 27. Divide by 3. My x squared equals 9. X equals plus or minus 3. But with a log, it has to be a positive number here, where that x is. So my answer has to just be x equals 3. Okay, so from here, log base 6, it's going to be x squared plus 9x equals 2. Okay, so hopefully you see we're just multiplying right there. Now, base raised to exponent equals this. So it's going to be x squared plus 9x equals 6 squared. So if I do the math there, x squared plus 9x equals 36, which is 6 squared. We subtract 36 on both sides. And I'm going to get x plus 12 times x minus 3. And my answers are negative 12 and 3. Now, I can't have a negative. Negative 12 doesn't work here, and a negative 3 doesn't work here. So this answer is no good. That's my only answer. It's got to be the 3. Okay. We clear with that? With subtraction, we're dividing. Log base 2. 8x plus 8 over x plus 5 equals 2. This raised to this equals this. So it becomes 8x plus 8 over x plus 5 equals 2 squared. All right, there's no log on this side, so I just can't set them equal. I've got to do the base raised to the exponent. Now from there, 8x plus 8 over x plus 5. 2 squared is 4. I'm going to leave it as 4 over 1. I'm going to leave it as a proportion. When I cross multiply, 8x plus 8 equals 4x plus 20. I subtract 4x. I get 4x. I subtract 8, and I get 12. And my x equals 3. And you'll notice 8 times 3 is 24 plus 8 is 32. 3 plus 5 is 8. 32 divided by 8 is 4. Guess what 2 squared is? 4. It should work out on every single level.